Next one. Gonna sort of look like the same formula, but a little twist to it again. This is a sample sum. It tells us our formula is z is equal to x bar minus n times the mean over the square root of n times the variance. So on these ones I did calculate n times the mean and n times the variance before I tried to plug it into my crazy formula. So it says a memory test consists of 35 tasks. So the n is 35. Each task is graded on a scale of 1 to 10. The score on the memory test is reported as the sum of the scores of the tasks. The mean score is 5.1. So my mean is 5.1 with a standard deviation of 3. Oh. What is the probability that a randomly selected examinee will score 164 points or more? 164 points or more, so I have to do greater than or equal to my 164. So, first thing we need to know is if they give me the standard deviation instead of the variance, that the variance is equal to the standard deviation squared. So my variance is going to be 3 squared, which is going to be 9. So then finding these two values here that I'm going to plug into my formula, n times my mean would be 35 times my 5.1. I'm going to let you go ahead and find that for me. Yep, that was the mean. So the 35 times the 5.1 gives us 178.5. And then I'm going to take n times the variance, so I'm going to take 35 times 9. 9 was my variance because I had to take my standard deviation squared. So 35 times 9 is going to be
1606.
Whoops.
Oh.
Did you clear it before you did that?
Oh,
Try 35 times 9. Make sure your calculator's cleared out.
315.
That sounds better. 315. Now notice again this one is a greater than instead of a less. Since our calculator does less, we got to do 1 minus in our formula. So we're going to do 1 minus p of z is less than or equal to. Our x bar is the mean, the value that we're trying to calculate here, 164, minus the n times the mean, which was our 178.5. Over the square root of the n times the variance, which is the 315. So that's how you want it to look when you punch it into the LS calculator. Oh, you already got it in there. And we're going to round off to 3 decimal places, so our answer is
0.793.
Yep, 0.793 is what we should get. So the x bar is the sample, or what we're trying to compare it to for the mean, and then we had n times the mean, which was that number, and then the square root of n times the variance, which was that number that we found there. Number 11. A biotechnology company partially finances 43 ongoing research projects at several North American universities. So N is going to be 43. The annual support granted for each project is determined by the progress of the project and has a mean of 22,748 and a standard deviation of 8,295. Again, if they give us the standard deviation, we really want to know the variance. So the variance, we're going to take that 8,295 and square it. We're going to have a nice big number. Go ahead and figure out what that variance is.
Six, eight,
68,807,025. Yep. The company has an annual budget of $1 million for supporting research activities. What is the probability that the support granted for the 43 projects will not exceed? If it's not going to exceed, that means it's going to be less than or equal to our $1 million. Since this is a less than instead of a greater than, I don't need the 1 minus in front, right? So I'm just going to do P of Z is less than or equal to, oh, I was going to say, it just blinked off on me. And all my numbers were gone. Whew. Came back. So, here's my value I don't want to exceed $1 million. I'm going to subtract, whoops, I didn't find my mean yet. I got to find N times my mean and N times my variance yet for my formula, right? So N times my mean, I'm going to take 43 times my 22,748. They couldn't give us any nicer numbers. What do we get when we take 43 times the 22,748?
978,164.
978,164. That's going to be the number here. On the bottom, we're going to do the square root of N times the variance, which we still need to find that. N is 43. The variance was this great big huge number here. 68,807,025. So if I take 43 times that number there, 2 billion something.
295870275.
Did I get it all down there? So that number there, 295870275 is going to go underneath the square root sign. So N times the mean goes up here on the top. The square root of N times the variance goes down there on the bottom. And then we're going to punch that in and round it off to 3 decimal places. Get all the right numbers in there. And be 0.656, right?
Yeah.
0.656. All right. So keep in mind, if it's a greater than, we do 1 minus that p-value. If it's a less, then I just use that value. And so we'll see on number 12 what we get. A small business owner estimates his mean daily profit as $970. My mean is 970. My standard deviation is 130, which means my variance will be 130 squared. I'll let you figure that out. $16,900. All right. His shop is open 105 days a year, so N is going to be 105. What is the probability his annual profit, again, will not exceed, means it's going to be less than or equal to that 100,000, right? I like it better when it's a less than. So, we're going to first of all calculate N times the mean and N times the variance. So N is 105 times our mean, which is 970, and then N 105 times our variance, which was 16,900. So 105 times our 970 gives us 101,850, and then on the bottom one, 105 times the 16,900. $177,450. All right. This is a less than, so we just have to do P of Z is less than or equal to. No, 1 minus. Okay, we don't want to exceed 100,000. So 100,000 is our X bar number, minus N times the mean was the 101,850 over the square root of N times the variance, which was the 177,450. 1,774,500. And again, we're rounding to 3 decimal places, so
0.082.
82, yep, 0.082.